Hello everybody. Chapter 18.8 deals about electric field inside a conductor. However, this topic is also known as Faraday's principle. You see here a picture of this man. He was born 1770 and died 1845. He has contributed quite a lot to the knowledge about electricity. So what is it all about? Let's assume that you have a solid sphere out of metal. Of course, inside you have the atoms, the nucleus and the electrons around. The whole thing is neutral since all these charges neutralize each other. What happens if you now put an additional charge? The idea is it will go anywhere. What if you place two charges? Then these two charges will go, for example, to this side and this side. Negative, negative, they are repulsive, so they try to be as far apart from each other as possible. If you take two more, they could go like that. Now what happens if you apply more and more charges? One idea might be that the charges they spread all over, so you have all over the place electrons. However, this is not the case. In reality, all these charges, I can just do a two-dimensional plot, will go to the surface of the sphere, and the inside is without any charges at all. This basically is the principle of Faraday. The proof of this principle is not that easy. As an idea, we can think what happens if we place an additional charge on the center. This charge then has a force to each of the other charges, and the average force of all charges to the other charges will be larger than if the charge is placed on the outside as well. So let's remove that again. Some examples. What happens with electricity in a car? So during a thunderstorm, you might be inside your car with tires, and the car is made out of metal. So if lightning strikes your car, you can be happy to be inside. All the charges will be on the outer surface, and the inside of the car remains neutral. Hopefully this will never happen to me, to you and me, of course, but you can also recognize that you have certainly never gotten an electric shock while inside the car. If you go to the car and open it, or if you close the door, you might have an electric shock, a small one, but never while driving inside the car. Never. Another example you have seen, or you will see on the video with the experiment with this so-called Faraday cage. If you listen to your radio, then you need an antenna to be able to get the signal from the outside. When you cover this with a metal, this is then referred to as Faraday cage, nothing happens anymore. You cannot listen to radio any longer. You can test that for yourself. Take your mobile phone, wrap it in aluminum foil twice, so you have to do 2 layers so that it's really tight, and then try to call yourself with another phone. You will see you have no chance to reach this phone any longer. The third example you have seen in the experiment concerning field lines. There we have placed a metal ring in the castor oil with the semolina on top. We have observed that we have electric field lines on the outside, but nothing on the inside. This is therefore the other way to say what happens here, or give a new formula. We can state that inside a metal, the electric field always is 0. This is also referred to as the shielding of a metal. If you have a plastic object, it can shield a little bit, but never completely. Only metals that conduct electrons perfectly are having this effect to have no field on the inside.